last time on this old power supply, we were goofing around and we blew up the sense resistor. Now, we wanted to find out how short circuit tolerant the power supply was, and it turned out it wasn't short circuit tolerant at all. So the small piece of wire put in here, expecting to detonate the wire basically, caused the 0.1 ohm current feedback resistor to open up. So the power supply locked up into constant current mode because the feedback was just spamming the op amps, and everything was kind of crazy. I couldn't figure out what was going on. And yeah, so we got our 0.1 ohm, our feedback resistors disconnected at the moment. So we've got no feedback and the power supply doesn't know what the hell's going on. So we ordered a replacement resistor. Can you believe that? Versus that. Because we're scaled up now. We're no longer in the 30 amp territory, we're in the 50 amp territory. So this is a 0.1 ohm resistor, 1%, and 250 watts. So this guy's still going to need to be mounted to a heat sink, because the spec sheet says in order for this guy to deliver its spec sheet ratings, it has to be mounted to a heat sink. So we'll try and find a heat sink. We've got lots of heat sinks, but we'll dig out a heat sink. We're also looking at packaging this system now that we're getting closer, although that's kind of a dubious claim because we've been working on this guy for 5 years now, I think going on 6. We wanted to put the main heat sink, main transistor assembly inside the rack box that this is going to ultimately end up in. However, that assembly is too large, and we need to include a heatsink component for one of the power resistors, and we were hoping that I could duct it with the resistor and the transistor assembly, and it's getting hot, so we'd like to have active cooling at this point. Now, that unit was designed from the get-go to mount piggyback on the back of the power supply. It was always intended to mount on the back of the power supply, but I wanted to try and see if I could put all the hot stuff in the box so that the user wouldn't get burned. Yeah, no, it's just not gonna fit. So we spent today, actually a couple weeks ago, we went off and we bought little fans so that we could figure out an air ram system. And then we found out promptly after buying the fans that none of that shit was going to fit. So today we spent some time bending some sheet metal and buying fans and getting parts together to try and figure out a piggyback fan unit for the power supply. And it looks like we've done it. So here it is. Now this is a good half a day's work, so don't be surprised about the results looking pretty good. We've got a decent fit here, and we've got these little studs that we nailed in. They're little number 6 threaded studs right here. There's nothing special. They're self-clinching studs. You could use PEM nuts, but the problem with PEM nuts is when you go to put the fan on, how are you gonna? You're gonna have to put the screwdriver through the hole. It's kind of, yeah. You can see, we've been working pretty decent today. So this is the basic assembly. We still need to hit it with some acetone. We jitterbug sanded it to take most of the scratches out. So you can see it's a uniformly scratched surface now. So that looks, there's some deep scratches in there, but this is industrial. No one really gives a shit. So here's the heat sink. There's no way to mount these fans on there. Absolutely no way to do that. Unless I TIGged, and my TIG welding skills are not that good. we could have TIG welded some components here. We could have machined it through with some brass rod. We could have put a hole through here and then had a cylinder with a thread in it and had a little like T-nut kind of thing, and that would have held the fan on there. But it would have held the fan, but it wouldn't have been ducted, which is good, but it's not as good. So we spent some time with our best friend here, El Cheapo Bendo. He works pretty good though. He's not a $6,000 bender or anything. And you know, we did a sample coupon first before we committed, and this is 42 thousandths, so it's going to give a little bit, which is nice because then you can stretch it a little bit. You can pull it one way or the other. It's a little bit springy. See, it's got that assembly. It's got that assembly. So we could glue it on if we wanted to, but it's going to get hot, so we don't want our customer getting cyanoacrylate fumes. So later what we'll do is we'll put a couple of screws in. It just needs 4. 1, 2, 3, 4. And we got the fans. And I got one correct size grill, and the other grill I got was the wrong damn size. How about that? And the store is closed tomorrow. How do you like that? Crappy. For the wiring, what we'll probably do is we'll turn the lugs inside so that they're both facing each other. If I can figure out where the screws are. We'll turn them so that they're both facing each other, and then we'll put a braided sleeve or some kind of a tubing on them, and we'll bond it with some silicone RTV. It's gonna look like shit, but that's kind of the way industry does things. We can use some of those little half round clips as well, but you know, industry, whatever, who cares, you know. We'll put kept nuts on these guys. Kept nuts are nice. Kept nut it. And then we're cool. Just doing our thing. And we still need to bend some sheet metal for this part. The back, this will be the back of the power supply. If you imagine this is the back, we need to bend a 17-inch wide sheet this way, and then we need to cut open a rectangular opening for this, and we'll do that next, maybe tomorrow, I don't know. But you can see all these lovely holes are all here. They've always been there since day one when we started the machining of this, that we intended to mount this on the backside. So unfortunately, we are going to have to continue through with that thought because it's not going to work otherwise. So that's it for now. Maybe you found it useful, maybe you didn't, I don't know. But thanks for watching.